Welcome back to Algebra 1. We're going to talk about the absolute most important thing that you will learn in Algebra 1 today. Some of you already know it if you have me for pre-algebra, but if not, you're going to learn it today, and it is dun-dun-dun, how to solve for x. Now, so how you do this is first we have to make sure of a couple of things. So this is Algebra 1, Chapter 3.1 in this book. Alright, so first of all, there has to be an equal sign. If there's an equal sign, we can do it. If there's not an equal sign, then we're not really going to solve for x. We'll talk more about that later. So first thing, all we have to do is check, is there an equals? Yes. Check. Now, what we do is we ask ourselves a series of questions and answer it. And our question here is, why is x not alone? And what I mean by that is, why is it not alone on its side of the equals? Why is it not alone by itself on one side of the equals like it is there? Well, the reason why it's not alone is it's got a -3 on the same side of the equals as it. Once you figure out why it's not alone, you do the opposite. And later we're going to talk about what to do if there's two different things. But right now we just have one. So we do the opposite. So what we have here is -3. What's the opposite of -3? That's right. It's +3. And you're allowed to do anything you want in math to an equation as long as you do it to both sides of the equals. So what you do to one side, you do to the other. So -3 + 3 is 0, but we don't write it down because we're trying to get x by itself, and if we wrote it down, it wouldn't be alone. So instead, we mark it out. Now on this side, we bring down anything we didn't mess with, and we didn't mess with the x, so I brought it down. We didn't mess with the equal sign, so I brought it down. And now we do this. 5 + 3 is 8. Put a box around it because we just solved for x. Now, you probably could have done that in your head. What -3 is 5? It's 8. But I don't want you doing it in your head, because eventually algebra gets too hard to do in your head. And what's more important is you learn how to follow these steps, and then you're going to be able to do it even when it's real hard and takes up a whole page. Right, let's do our next one. Why is x not alone? It has a +6. What's the opposite of +6? -6. What I do to one side, I do to the other. These mark out. I bring down what I didn't mess with. 10 - 6 is 4. Put a box around your final answer. Okay, let's try another one. X is alone, but this is not one thing, it's two things. So here what we actually need to do is sing and dance. Gathering up your terms, 2 on each side, stowing away the time. Because we're going to gather up these terms of 8 and -3. To be able to add or subtract, they have to have the same letters with the same exponents. They have the same letters, no letters, with no exponents, so we can do it. So 8 - 3 is 5. Now this one, there's nothing to do. X is already by itself. I'm just showing you that it can be on either side of the equals as long as it's alone. Okay. Equations are called linear equations if they just have x. No x squared, no x to the 3rd power, no 1/x, anything fancy like that. As long as they just have an x, if you graph them, they make a line. So they're a linear equation. And we'll learn more how to do that later. Let's do this one. Why is x not alone? It's got a -5. What's the opposite? +5. What we do to one side, we do to the other. We mark those out. Bring down what we didn't mess with, the x and the equals. -13 + 5 is -8. Ta-da! Okay, let's do this one. Why is x not alone? Well, we got more problems than it not being alone. We have something ugly. So sometimes instead of saying, why is it not alone? Before we can say that, we have to go, Why is it ugly? And what's making it ugly is two negatives in a row. So I'm going to fix that first. What do two negatives make? That's right, a positive. So I'm going to bring down what I didn't mess with. Make those two negatives a positive because they're multiplied. Remember, parentheses mean multiply. Now I can say y is x down the line. It's got a plus 4. So what's the opposite? Minus 4. What I do to one side, I do to the other. These cancel out. I bring down what I didn't mess with, and x equals negative 12. Whoop, whoop, whoop. More fun with sound effects. Okay, in your book there's a word problem, and it says, somewhere the temperature changed from 54 degrees to negative 4 degrees. How much did the temperature change? A triangle in math is the Greek letter delta, and it means change or difference. Now what makes this tricky is it's not 50. Because it's not 50 minus 4 is the Fahrenheit degrees. We have to go from 54 to 0 and from 0 to negative 4. So how much was our temperature change? It was 58 Fahrenheit degrees. Notice how you usually say negative 4 degrees Fahrenheit. If you put the degree sign on the other side of the Fahrenheit, it means that it's a temperature difference and not a measured temperature. That's a little math thing that most math teachers don't even know because they're not physicists. All right, so that is your introduction to solving equations. That wasn't bad, was it? You're going to be fine. It's going to be fun. You're going to enjoy it. Math is fun.